All right, so can everybody see that?
Yep.
Perfect. Okay, so welcome everybody. This is a small group, so we can make this pretty informal. I think that we met yesterday, and we had talked about if folks have questions as we go through. We're thinking kind of save the questions at the end, but since it's really just John and Christine for now, I would say, if you've got a question about something that pops up between anybody's slides, just feel free to kind of either put it into the chat box or, chime in. I think, we were thinking if this was a larger group, we would wait till the end, but since it's a smaller group, I think that's fine. So I'm going to jump sort of right in, and we'll kind of introduce the team real quick. And then I'll kind of get into today's agenda and we'll go through this. So first, I'm Kyle Pimentel. I'm the Principal Regional Planner at Stratford Regional Planning Commission and was one of the project team leads for SRPC in terms of organizing and putting together the plan. Renee Bordeaux was one of our consultants from Septic, but wasn't able to be here this morning. So I'll let, how about Jamie, you can go next.
Sure, I'm Jamie Houle. I'm the director of the UNH Stormwater Center. So we've been just on the project looking at structural and non-structural best management practices for nutrient control primarily.
And Don?
Yep. So I'm Don Kretschmer. I live just up the road in Wolfboro, and I was kind of the water quality lead for the in-lake stuff and some of the watershed modeling. And that's kind of what I do for a living.
And Sally.
Hey everybody, it's good to see you all again. I'm Sally Soul, and I work for the New Hampshire Department of Environmental Services. And just sort of a reminder of my role is that I manage grant funding to assist folks in developing watershed-based plans, which we just accomplished with the help of you all. And I think it's a good plan and it's a really solid plan. But today I'll be here to talk about the implementation funding that we have available to implement the recommendations that are in the plan. So this is sort of an exciting phase. The box has been checked, the plan is done. And now projects that are in the plan are eligible to receive funding to be implemented. So I think we're kind of at a great point here where we're sort of turning the corner from planning to actually, as I like to say, digging holes and building things and cleaning up water. So it's an exciting day. Thank you.
Thanks, Sally. And I will say I did offer an opportunity for the rest of the project team to use a more fun photo. Nobody took it up besides myself. So just want that to be on the record. So in terms of today and what we want to accomplish, what I'm going to do is just give a brief refresher about the project background, how we got started, and a little bit about the process, how we engaged the public, how we got our information, and how we kind of went about pulling all of this together. Then I'll turn things over to Don to really give a summary of the findings in the plan, to talk about the water quality conditions and the lake characteristics, and a little bit about what some of the goals that we've set. Then Jamie will kind of come in and talk about the structural and non-structural BMPs, actions that we put together as part of the project. And then, like Sally mentioned, she would sort of close things with this call to action about what we can do to take next steps now that the plan is done, and now that this is going to be eligible for 319 funding and potentially other funding. What we can do to start picking away at the plan, and what actions the town may wish to kind of take on next. And I think, Sally said it really, great that, this writing the plan is writing the plan. I mean, it's not all that exciting. We had a chance to really learn a lot about the lake and, learn a lot about, some of the land uses in and around the lake in Middleton, but really, this is where the rubber meets the road. We have an opportunity now to implement this plan and start actually making some changes, and hopefully changes that will lead to improved water quality. So This is really where this is kind of the more exciting part of watershed planning. And so we've kind of checked that first box, but there's sort of a lot of work to do, and Sally will talk more about that kind of anything. So just a little bit about the project background. We first applied to DES back in June of 2020, or that's when it was awarded. I think we even applied a little bit earlier than that. But we did receive a grant through DES's 604B program in the order of $64,000. We were, one of the more competitive. I mean, I think they only funded, Sally, correct me if I'm wrong, only one project. So I think it was just the Middleton. I think this is the only project that was funded in that grant round, which means that it scored really high. And so, funders saw this as a good opportunity and money well worth spending to address an ongoing issue. So, so we were really happy with getting that funding together. And then, thinking about what we really put into the application and what has kind of been our overall, large goal for this project, you set sort of three of them. One, improving lake water quality, reducing any algal blooms, and then also achieving a reduction in phosphorus floating. That's kind of been, the three primary goals that we've set from the very beginning. So once we got the funding, the first thing that we did is we went through an RFQ process and looked for qualified candidates to, act as our consultants for the water quality piece and kind of putting together some of the stormwater BMPs. And we had some really great candidates, but ultimately the project team consisting of myself, Elena and Autumn at SRPC, along with Sally, we went through a process and ultimately selected Geosyntec as the consultant, and their team that they had put together in the application also included Don from TK Water Resources and Jamie from the UNH Stormwater Center. I think one of the things that we really appreciated was the team that they put together brought multiple levels of expertise. Geosyntec on the engineering side, Don for water quality and lake monitoring, and then Jamie for stormwater. We saw it as a really strong team, and what they laid out on how they were going to do all their work was something that we felt was a really good fit for what we wanted to accomplish. So after we got together, we did some preliminary GIS analyses. We did a little bit of ground truth or some research to kind of collect some initial data that we presented in a kickoff meeting that was held almost a year ago today, back in January of 2021. And that was really to provide stakeholders with a couple of different opportunities. We wanted to allow them to learn more about the scope of work, what our schedule was going to be. This was a relatively quick process. We held that meeting last year, about a year ago, and we wrapped up the plan within that time frame. Had an opportunity to have a face-to-face with folks, whether that was any of the select board members or a few members of the Conservation Commission, the road agent, some of the chairs for the homeowners associations. Opportunity for us to meet them and for them to meet us and ask any questions. Also to hear about some of the initial data findings that we found. And that was really a lot of Don's work with some of the lake characteristics that they had pulled together. And then ask questions about how they could get involved. We did try to do some sort of local outsourcing that I'll talk a little bit more in a second. But we sort of left things at that meeting with how people could participate in the process and where there would be future opportunities for them to contribute. One of those ways was by filling out a septic system survey that we passed out. So this was something that the Planning Commission put together. It was just a one-pager. We posted it to the town's website. We also distributed it to any lake owner or any property owner that was within 250 feet of the lake. We also made digital copies available online. We did some person-to-person mail-outs. We ended up with, we were sort of set a target goal for ourselves of 30%. We came in just below that. So we received about 27% response rate. So I want to say that there was just over 210, I think, that were delivered. And so I think we were somewhere between 50 and 60 responses, which is pretty good. You know, obviously didn't quite reach our goal there, but I mean, I think that the information that we received was good, and that fed into that information that we collected was given to Don to help feed into the lake model. Another opportunity was we offered a Soak Up the Rain educational program, and that happened over the summer. And so that was something that Lisa and Sally and others helped coordinate. We had 16 residents that were interested in or participated in that event. 5 of them ended up signing up for soak evaluations, and those were conducted in August. All the results and you know, the recommendations are within the plan, so folks can read about more of that that's in the plan. And I think we've got some slides later that talk a little bit more about that. But really, you know, what that was intended to do was provide some face-to-face with homeowners on how they could move forward with some solutions for managing, you know, existing stormwater that's on their site. So whether that's, you know, a rain garden or diverting water a different way, you know, whether it was landscaping or something different. This is also a program that, you know, if there are residents that are interested in this moving forward, that we could work with DES to, you know, to conduct either additional evaluations or another program. You know, this is something that's kind of an ongoing thing that could go on after after this project is wrapped up. I mentioned earlier sort of trying to outsource some information from folks that lived in and around the lake. And so we put together a flyer, this stormwater reconnaissance flyer. What we were really looking for was for folks to let us know if there were areas that they recognized as hotspots for us to look at when we did our in-field investigation. So whether there was erosion or clogged culverts or, you know, flooding and washouts, we were looking for that information on where those sites were. So when we came up, you know, we could go directly to them to look to see, you know, what the issues were and how we might want to address them. And so we did have a list from a few folks that had submitted thoughts that when we came up there, we went and visited those sites. In addition to the land-based field investigations, John was you know, he was gracious enough to take us out on his boat, where we were able to go and get a different view of the lake's shoreline all the way around. And so again, this was looking at, you know, what structural and non-structural stormwater BMPs could help to address some issues, and Jamie will talk a little bit more about that. And so, you know, I'll sort of end this, you know, process and engagement piece by saying, you know, there was a lot of work that was done over the past year. We, in addition to all the field investigations, to all the research, you know, talking with John and others, and gathering all that information, we also had project team meetings every month, different coordination meetings between the group with DES, going back and forth, kind of, you know, figuring out what we needed to do, what else we kind of needed to pull all this information together into the plan, and to make sure that we were hitting all of the elements that were required in that A through I plan, to make sure that it was, you know, eligible, you know, to make sure that it meets all the sort of the compliance for an A through I watershed-based plan. And so, you know, I'll close and I'll sort of turn things over to Don by saying, you know, one of the key pieces that we came to was what our water quality goal was, and that's a total phosphorus reduction of 20%. And so how to get there over the course of the next 10 to 15 years. And so I will stop there and turn things over to Don to talk more about where the existing conditions are for water quality and moving forward, how we might be able to try to sort of get to that 20%. So Don, I'll turn things over to you, and if you just want to let me know, I'll move the slides forward for you.
Great. Well, thanks, Kyle, and thanks for all the kind words about the team. I mean, it truly was a team effort. It's been really nice for me to work on, a local lake that I drive by. I've been driving by at least 2 or 3 times a week, probably for the last 25 years. It's kind of my way south out of town and to the seacoast area. So I've had an interest in that lake for a long time. I witnessed some changes there over the years, and it's been really nice to work on it and look at things in a little bit more detail. So we can go to the next slide. So this will come as no surprise to anybody who is familiar with Sunrise Lake. It's really shallow. And that's important for a bunch of reasons, which I'll get to in the next slide. But it's it's important that the water does turn over fairly rapidly, and pretty much what you see is what you get. There aren't any deep zones in the lake where processes are happening that you may not see. You can see the bottom in a large portion of the lake, and the water quality that you see is reflective of what's going on in the lake as a whole. So we'll go to the next one. So here's some characteristics that turn out to be pretty important to what we're doing with the planning. And like I said, it's very shallow. 6.2 feet is the average depth. You can almost stand up. I can't. It'd be over my head, but some people could. At the average depth. One of the important ones is the flushing rate, 3.2 times per year. So that's, a little over 3 times a year, all of the water in Sunrise Lake is replaced with water from the watershed and from groundwater. And so what that tells us is that, the lake water quality that you see can change rapidly with a big storm or a series of big storms like we had this summer in July. I mean, that can change water quality fairly significantly. And so, the water quality in the lake is much more reflective of what's happening sort of on a shorter time scale than a lot of other lakes, like Winnipesaukee, for example, where the flushing rate is about 20% of the lake a year. So it takes 15 years or 5 years for it to flush once. So 3.2 times a year is fairly rapid, and that becomes important when we do some of the modeling. But on the plus side, you're going to see improvements in the lake if you can reduce the amount of phosphorus that's coming in fairly rapidly. There's no big lag time here that we'd be worrying about. So that said, where you are right now for phosphorus, and I'm going to talk about why that's important with the next couple slides, is about 9. We'd like to be below 8 to give you the best chance of not experiencing cyanobacteria blooms and having satisfactory water quality and water clarity. Chlorophyll A, which is a measure of how green the lake is a little bit higher than we'd like to see. And by reducing phosphorus, we should be able to reduce chlorophyll A. Transparency, how far down you can see in the lake, is a little lower than we'd like to see. And by reducing chlorophyll A through reducing phosphorus, we think we can increase the transparency. So next slide. So phosphorus is the most important nutrient in lakes for growth of algae and cyanobacteria. That's what we're focusing on for this plan. It's also the middle number on a bag of fertilizer. That's nitrogen, phosphorus, potassium. Phosphorus is that middle number. If you feel like you need to fertilize around the lake at all, that number should be 0. I always I'm of the opinion that if you live near the lake, the last thing you want to do is cut your grass on the weekend. You want to be out on the lake, so why fertilize it? And it turns out we have plenty of phosphorus naturally in our soils anyway. So, you know, don't fertilize unless you absolutely have to if you live near the lake. Next. So this is how we sort of figured out that phosphorus was important. Colleagues up in Canada did an experiment where they took a lake and split it in half. And the only difference between the two halves, the upper half and the lower half, is that the lower half had phosphorus added to it, in addition to nitrogen and carbon. The upper half had nitrogen and carbon, and lo and behold, shortly after the addition, the lower half turned green in response to the additional phosphorus. So next slide. So I did a little experiment with my daughter back in 2007. And the only difference between these two jars were that I added phosphorus lawn fertilizer to the one on the right. We set it in the windowsill for 2 weeks, and look what happened. It turned green, and it was pretty clear illustration. My daughter got it at that point when she was only 9 years old. So I think, you know, it's a pretty strong message to put out there. Next slide. So why might we worry about cyanobacteria? There's been a couple instances where there's been blooms of cyanobacteria reported in Sunrise Lake. They can be toxic. They're not always toxic, but they can be toxic to zooplankton, fish, wildlife, pets, humans. They can cause odor and taste problems. If you've been near a lake that's blooming really, really badly, you can smell it. Aesthetics, it doesn't look great having floating green scums. There's problems with swimming, problems with water clarity. You can't see the bottom, you can't see your toes when you're swimming, and light penetration, which ends up shading a lot of the natural growth that would normally be on the bottom. And sort of a overarching concern is lakes that have cyanobacteria blooms can have loss of property value and loss of tax bases to towns that depend on them. And that's something that's probably pretty important in Middleton. Next slide. So the basis of the modeling that we did was the volunteer monitoring data. And, you know, I'm not going to go into the numbers in great detail, but I think what's important to say, you know, about this slide is that, you know, it's been great that you guys have collected data over the course of the past 20 years or more. I think that going forward, while you're in this active management phase and sort of monitoring how you're doing, I'm going to make some recommendations to maybe increase the frequency. Much of the data that you have is once per year. And because the lake flushes so often, I think water quality is pretty variable over the year. And you're going to need to take more, you know, collect more samples to get a handle on how it goes up and down over the course of the year. Next slide, and I'll talk about that later. So these are the plots from the Lakes Lay monitoring program. I want to pay particular attention to the red line, which is the amount of phosphorus, and sort of where we would want to be to ensure that we didn't have algal problems or bloom problems would be below 8. And as you can see, you know, starting in 2010, we had, you know, significantly above 8. A couple of years of significantly above 8. It dropped down and bounced around a little bit. And concerningly, you know, in 2019, we're back up above 8. And right now, you know, I think the concentration is sitting around 9, which is higher than we would like to see it. I think a 20% decrease, which I'll talk about in a minute, would get you well below 8 and safely in the zone where, you know, you could expect blooms to be very infrequent.
Don, that 2009 was, I believe, when the lake was drained totally.
Yep.
For dam repair.
Yep.
Right down
okay,
to
well, that's a good thing to know. That data, you know, that's good to know. That data did not go into the model because I used 2010 to 2019 data. So, but it's good to know to explain that piece of data, the anomalous piece. So that's great. Thanks, John.
If I may add, that lake, surprisingly, they started filling in July, and it filled by September,
Right.
and that's in the middle of summer. That's
Right.
pretty quick.
Yeah, yeah.
That's a lot of water.
That's a lot of water, right? Okay, next slide. So where do you guys fall out? Where does Sunrise Lake fall out amongst some of your neighbors? And I kind of threw this figure together to kind of give you an idea where you're at. You know, if you get higher in the phosphorus amounts, you get to, you know, I put the background behind it to just give you kind of a sense for whether you were going to have a green lake or a primarily blue lake or a clear lake. And Sunrise Lake is right in the middle. Like I said before, it's right around 9. And there are some lakes around that are greener. Chalk Pond in New Durham is just a little bit higher. Bellow Lake and Province Lake up in Wakefield are quite a bit higher. And there's a number of lakes that you would know, you know, you'd be familiar with that are lower. Mare Meeting Lake, right around the corner in New Durham. Shaw's Pond, just up the road in New Durham. To the north, Pine River Pond, Lake Wentworth to the north, Bow Lake to the south. All of those are lower than Sunrise Lake. And most of those lakes that are lower have very rare or, you know, non-existent cyanobacteria issues. And so that's kind of where we want Sunrise Lake to end up, in that category and with that group of lakes. Next slide. So the modeling we did helps us understand how much phosphorus the lake can take and kind of where that phosphorus is coming from. And then, you know, down the road, it gives us a way to prioritize best management practices and lets us predict what lake might look like if we fix certain things. And so we'll go to the next one. So the model we use is called the Lakes Loading Response Model. And on the top, you can see all of the watershed sources, everything from atmospheric to waterfall, septic systems, agriculture, logging, development, roadways. All of those things are accounted for in the model. And where, you know, these are sources of where the phosphorus comes off the land. There's a couple sources on the far left, internal recycling and point sources, neither of which are present in Sunrise Lake, which is great. Those are both 0 right now. And then sort of on the bottom, we put all that phosphorus in the lake. We go through some in-lake processes. There's some equations in the model, and then we can predict what the phosphorus concentration would be in the lake and how green the lake would be, which is represented by chlorophyll A, the probability that you're going to have an algal bloom, and the mean Secchi disk, or how clear the lake is. So we can go to the next slide. So Geosyntec did this land use distribution, and I think it's, you know, critical to the modeling to get this piece right, and I think they did a great job with it. But superimposed on this are sort of the watersheds. And if you look, you know, most of the watershed of Sunrise Lake, or the land that drains to Sunrise Lake, is in Hampshire Brook and Tanglewood Brook. And fortunately, much of those watershed, you know, much of the land in those sub-watersheds is undeveloped, which is great. And that really helps protect water quality and sends high quality water to Sunrise Lake. Near the shore, all of the direct drainage areas are highly developed. And as we'll see in a minute, a lot of the nutrients that are coming to Sunrise Lake end up coming from those areas. And those areas are the areas that are focused for some sort of best management practices to reduce that loading. So on to the next one. So the model predicted phosphorus sources to Sunrise Lake. And this is just sort of the first broad brush. I think that, you know, one of the things that's pretty clear is that about, you know, maybe 20% of the loading comes from septic systems. Probably 60% comes from the watershed. I think some of the modeling I did later on will show that both of those have to be addressed in some fashion to meet the water quality goal. There's other sources like direct atmospheric. This is what comes in through dust and rainfall. There's not a lot you can do with, you know, do about that locally. Right now, there are some waterfall sources. There are some things you can do with waterfowl, but it's not a huge piece of the overall pie. Nonetheless, you still don't want to feed waterfowl, and you don't want to you want to discourage them from lawn areas and things like that. Okay, next slide. So this is a pretty important slide. If you look at sort of the land cover in the watershed, on the left, you can see that 75% of the land cover are natural, what we call natural uses. And those are things like forest, wetlands, but undeveloped uses. And only a quarter of the watershed is developed. But if you look at the amount of where the phosphorus load is coming from to the lake, overwhelmingly, like 82% is coming from the developed part of the watershed, and not the natural uses. So that's pretty important, and that illustrates that it's sort of the altered environment where the sources of phosphorus are coming from. I did a quick exercise, and it's in the plan, where I took basically all of the entire watershed and turned it back to natural uses, and the phosphorus concentration in the lake would be somewhere around 3 micrograms per liter, down from 9. So clearly, the developed portions of the lake are what's driving what's happening. Okay, next slide. So this just is a quick illustration of the land area by subwatershed. As you can see, Hampshire Brook and Tanglewood Brook are the largest by far. And the other ones are relatively small, but in terms of phosphorus impact are fairly high. Okay, go to the next. And so this is the phosphorus load by subwatershed. And you can see that all of the direct drainage areas all increased relative to their size in terms of their contribution to phosphorus load. Hampshire Brook and Tanglewood Brook are still large sources, but that's not surprising since they're really large areas. So I decided to look at it a little different way to give an idea of sort of where the density and the most phosphorus per unit land area was coming from. So that's the next slide. So if you look on the left, this is the total kilograms per year coming from subwatersheds. And because Hampshire Brook and Tanglewood Brook are so large, there's a lot of phosphorus coming from them. But if you look at it on a per unit area on the right, you can see that the direct drainage areas are really, really important in terms of phosphorus. And they're important not only because the phosphorus is being input into the lake right near the lake shore, the impact is very close to the lake, but also it's where all the dense development is. And this is where the opportunities for fixing things are. And there's a lot more explanation on this in the report. So go to the next slide. So we took the model, and on the far left here is kind of where you're at with current conditions. The dashed line is sort of where the target is, and then we ran a bunch of scenarios to try to figure out how we get to the target. And if you look at structural BMPs only, which is the third panel over, that doesn't get you to the target. And these are ones that we've identified. Non-structural BMPs only, that doesn't get you to the target. Septic system improvements only does not get you to the target. But doing structural, non-structural, and septic, a little bit of everything gets you to the target. And I think that that's the important, takeaway message here, is that you got to do a little bit of everything. You can't do just one thing or the other. You got to take phosphorus out of each of those buckets in order to reach your target. Next slide. So I'm going to talk briefly about monitoring before I pass this off to Jamie. So this is, we're recommending that this be done going forward, and it doesn't have to, you don't have to ramp up to this immediately in the first year. So what we're recommending, and this is typical of what we recommend in a lot of lakes, and it's very similar to what's being done in Merrimating, up in Wentworth, a whole bunch of lakes in the area, is 5 in-lake monitoring events per year. And there's more detail on that in the plan. But what I like to see is sort of a immediately after ice out in-lake monitoring event, 3 events over the course of the summer, and then an event at the end of the year after the lake turns over, which would be probably mid-October. And those, don't have to be really elaborate events, but I'd like to see, phosphorus, color, and chlorophyll A collected from, the deep spot in the lake. The monitoring events in the tributaries. So I'd like to see one of those in the spring when we have spring runoff before the leaves are out. The trees and the greening of the watershed ends up taking up a lot of the nutrients. I'd like to see what's happening before that. And by tributaries, I'm kind of looking at Tanglewood, the three big ones. And there's an unnamed tributary as well. So Hampshire, Tanglewood, and the unnamed tributary. So those 3 spots, if you can grab a sample there, in the spring, in the middle of the summer, during a rain event, and again in the fall, that would be great. And so I see John had a question in there, and absolutely, we can recommend some equipment, and I think we can work with, you guys can work with Bob Craycraft to get the equipment you need. And I don't think it's anything too elaborate.
Yeah, I've already explored that a little bit with my VLAP coordinator.
I'm sorry. I said Bob Craycraft. That's LLMP. That's the other. So you're talking about VLAP, and this is Sarah. Right?
Well, all this. I mean, you have in lake, and then the tributary. To get the in lake, I think we can get away. I mean, some of that test equipment, if you get everything, is like $4,000 or $5,000. It's pretty salty. Mm-hmm. But there are some starting test kits that are available that I've seen that are a lot less than that. Yes. I don't know what's involved with the sampling of the streams and what that would entail. So we can talk about that offline. We don't.
Yeah. I mean, the sampling of the streams is actually, a direct fill of bottles you would get from the volunteer monitoring coordinator. So there's really no equipment needed. I mean, sometimes it's helpful if it's not great access to have a dipper, but beyond that, it's pretty straightforward stuff.
Okay.
So, and then the last component, and there's more detail in the watershed plan on this, but the last component is to do some additional sampling.
I went into it the same way, like with Michelle. What I do with Michelle, I have to go into inbox first, and then you can get into it.
Carol.
Look at my picture.
Carol, please. There you go. Thank you. All right, go ahead.
Everyone multitasks, so that's okay. So during blooms, if you have a cyanobacteria bloom, I would strongly encourage you to go out and get a phosphorus and a chlorophyll measurement to try to figure out, we want to start to have a pattern for sort of what are the trigger values to make these things happen. And you also want to have a phytoplankton ID done, probably by the state, just to find out what species it is that you're dealing with. So with that, I'm going to pass this back to Jamie.
Great, thanks, Don. So, I'm here to talk about some of the exciting things, like what can we do? And we typically break up the management activities into 2 real classes, and we call them structural and non-structural. Structural being things that, holes in the ground, things that you install, that intercept flow streams and manage and treat the water. Non-structural are actually more diverse by nature and can include anything from outreach and education to policy or regulation changes that can improve long-term reductions or long-term control of nutrients, to what we'd call good housekeeping measures, things that you do routinely, like sweeping streets, leaf collection programs, and other things like that, catch basin cleaning if you have catch basins. So we'll talk about those separate. So first, next slide, please. We'll just talk about the structural controls. And again, we evaluated several sites. And as Don said, there's really not a lot of development. So obviously we like to target you can forward it, Kyle. We like to target areas of impervious cover, and the largest area being in this region being like Middleton lumber. And of course that's completely outside the watershed. So without a smoking gun, if you will, of impervious cover in large expanses of manageable impervious cover, we tend to target things that have high visibility that can also double as education opportunities. And so we focused a lot on boat launches and public areas. So this first case being Hampshire Shore boat launch off of Shore Drive. And again, this is a highly visible area. And are we going to get huge load reductions? No, but we can use this as a demonstration area to demonstrate how to disconnect some of the impervious cover into small depressions we call rain gardens. And then coupled with signage can, again, go a long way to showing that these areas are committed to load reductions and demonstrating, how simple this can be. So here we proposed some depressions right along this road edge. So here the parking lot kind of sheet flows into the beach area, and we can really intercept that sheet flow with swales or rain gardens, or really what we're talking about is depressions with engineered soil, place for water to go, and some vegetation. And so these are marginal costs. We estimate a capital cost of $16,000. This can be leveraged using the grant funds that Sally will talk about, or it can be kind of done by the municipality itself. So there's a range of implementation efforts, and we're just showing you a conservative estimate of what it would cost if you kind of hired this out.
Hey, James, can I clarify something? This is Eric DeRoyce. I've got a property on Pinkham Road. This to me does not look like the boat launch. It looks like the Hampshire Shores picnic area in beach. Just to clarify.
Great, thank you. Yes,
Okay.
we probably, that's a misprint on our.
Okay, I just wanted to point that out before this got too deep.
Right, there's a beach area. There's not a boat launch. I agree.
Right. We have a boat launch, but it doesn't look at all like that. Sure.
Yeah, thank
Okay.
you.
Yep.
So again, the cost here could be minimal. It could be leveraged by a grant fund, but we think that this is a good opportunity. One, to demonstrate, the landowners are committed to load reduction, and to demonstrate what can be done even on private properties. So next slide. And again, so the next place, these are town of Middleton properties, and they're right next to each other, right off of 153. And one is the Canoe boat launch. And so here, this one, obviously you can see erosion from the picture down where vehicles back up and where the pavement sheet flows down. Here, the launch is really acting as a conveyance to the lake. And so you could do multiple things to stop erosion down this conveyance. And then the launch and the launch activity itself is a source of phosphorus due to just the we'd call the launch non-conforming, meaning that the standards that are in place today for boat launches are really not met by this. This is a kind of a old, outdated launch facility. So there's no stabilization of the launch area. So vehicles are actually backing up into the lake itself. And that, of course, causes disturbance of the sediments and resuspension. And this is what happens in turnover activity. So you're resuspending the solids and you're making potentially that phosphorus that's bound to those sediments available in the water column to other things during these periods of launch. So there's two activities here. One is some stabilization, which is relatively cheap. And again, the cost to have someone do it, we estimate around $10,000 here. And that can be leveraged by, having volunteer or town equipment do some of this work as well. And then stabilizing that launch, and we're just estimating a $15,000 to $30,000 price tag. There's high potential for public, the visibility, and high potential for some load reductions from that activity. But these costs are estimated largely because boat launches now are heavily regulated. So to come into conformance, you need specific slope, you need specific stabilization, and it's something that could be explored. Again, if that rises to the top as a management activity that you want to pursue. Next slide. Just adjacent to this site is the Jones Beach picnic area. And again, this is an area that gets high public visibility. You can see some erosion right along these boulders, and that continues down to the shoreline. And so again, our approach is arresting that, intercepting that runoff by depressed areas where we'd have vegetation, and also signage to promote, again, the town's commitment to reducing erosion and nutrient flows that would be coming off of the pavement 153. Next slide. And the final spot we centered on was the Sunrise Lake Lands Association Beach. And again, there's a high density of population here, a lot of activity around this beach, and there was some historic, flooding or erosion problems in the beach itself. And so, we looked at this location, we saw some potential areas for retrofit, but what was communicated to us as the biggest problem was erosion down the beach itself. And when we were there, it was really kind of confounding to me how that could be happening. And it piqued my curiosity enough to come back with some visual equipment and scoping, and we brought some sensors to do some additional monitoring. One, because we wanted to also look at the adjacent Tanglewood tributary, and we wanted to kind of quantify so again, according to Don's modeling, we see the Tanglewood watershed, albeit large, as a very low contributor to potential pollution. And we just wanted to verify that or validate that with quantitative information. So what I'm going to do now is, Kyle, if you could stop share, and I'll share my screen and just go over some of the results that we got from this particular analysis that we did. Hopefully you can see my screen. Looks like you should be seeing a big chart with lots of numbers. And the thing to really key in on is this is monitoring of a real-time sensor that we have looking at that Tanglewood tributary in stream. And the thing to focus on is the nitrate and phosphorus, total phosphorus, which are the very bottom of the scale. And these are what's bioavailable. And so these are what's threatening potentially water quality and cyanobacteria blooms. And you can see these are really low. And what this indicates to me is it validates Don's modeling assertion that the tributary itself doesn't have high potential to cause or contribute to pollution. And we followed that up. Whoops, I'm sorry. I started that in a at the end. So let's see there. We also followed that up with grab sampling. As we discussed, this would be something that the monitoring program could, the VLAP program could continue to do. And if we look at the range of results, this is the tributary to, that's the Tanglewood tributary, and this is the beach outfall. So that outfall that runs just between the beach and some adjacent properties, and also goes into Sunrise Lake. Really, the things to key in on, again, are phosphorus, and we can see we're really low. So this is a grab sample that was taken during the time of the real-time monitoring. And you can see we're right around 0.04 milligrams per liter. That's 4 micrograms per liter, or 4 parts per billion. And it kind of is consistent and verifies, again, Don's model assumption that if there wasn't these concentrated areas of development, your baseline conditions would be dictated largely by the large tributaries, and we'd be right around 0.03, 0.04 milligrams per liter, 3 to 4 micrograms per liter. One of the things that jumped out here is we also look at E. coli. And again, the tributary is very low. Here, the action limits are around in the hundreds. So, the one thing that jumped out is we did have high hits in that tributary or the culvert that is dumping into the lake that drains a lot of that developed area around this beach location. And then finally, I just want to show you a video. I'll reduce the sound because it's really not entertaining. But we scoped up into the culvert, because again, it was confounding to me why you would have any erosion problems in the beach. And I won't go into all the details, but just hydraulically, nothing that shouldn't happen unless there's something going on. And so we really targeted this culvert, and this is looking up the culvert from the point of discharge to the swale that enters into Sunrise Lake. And I'll just play this out. And what we zero in on is a gaping hole in the corrugated metal. And this isn't uncommon, but I'll stop it there. And what you're seeing is water running down the culvert. Again, the road would be upstream into this big gaping hole in the pipe. And so really, if this culvert were solid, it would just be running down into the swale, into the lake. But here it's dropping into this mysterious hole. And I can tell you that my assumption is that hole is then that where that water is going, it's not going underneath the pipe, it's going to the beach, and it's popping up and causing the erosion problems that they're having in the beach. So the Homeowners Association was looking into all kinds of methods and ways to reduce this. And we really recommend either slip lining this culvert or replacing this culvert. This is only about 20 feet into the culvert, so it would be really easy to replace this section of pipe. Again, corrugated metal in northern climates has a very low life expectancy, largely because salt and erosive activity from lots of sediment. And so that's probably what happened here is over time, high chloride water kind of just ate the pipe away. And and you get this breach in continuity of the pipe that's causing erosion problems somewhere else. So again, how do we estimate the load reduction? It's really hard to. We didn't in the plan, but we know that the attendant erosion that happens from this breach in the integrity of the pipe can cause not only sedimentation in the pond, but also phosphorus migration as well, in addition to just the nuisance and the expenditures that are being routinely incurred as this happens during high rain events by the association. So that was kind of exciting. It was kind of neat to kind of scratch our heads out there and say, this shouldn't be happening, and then explore and really find, we didn't find many smoking guns. This is one of them. So, and pretty easy to remedy. All right, so Kyle, could you reshare? And then advance, and we'll go into non-structural. So again, non-structural controls, this is a very broad category. This is everything else. This is outreach and education. This is policy and regulatory updates, be it for buffers or stormwater management from incurring development and redevelopment activities, or septic regulations, and all the way to good housekeeping, street sweeping, leaf collection, and other activities. So you can advance. And so, yeah, John's commenting, replacing the pipe would mitigate the erosion in the beach. Absolutely. Would it address the E. coli? The E. coli hit is really just a red flag that says we need more investigation there. So it's really inconclusive right now as to, I would start by saying we know from all of our previous work that bacteria are prolific in nature, that just having high bacteria counts doesn't necessarily constitute a problem, because there could be bacteria just living and existing in the pipe. So these, although this is E. coli, it's assumed to live, it'd be enteric, like live in the intestines of mammals, but it's prolific in nature, and it likes to, it's very hydrophobic. It doesn't like to be in the water column. It largely attaches to sediments. So if you have areas of high erosion, that could be, a cause of high bacteria counts. So it's a red flag for further investigation. And so that's about all I can say right now. We'd like to continue to investigate. And I did take a sample and sent it to our genetics lab, and that they process it and look at S16 RNA, so bacterial RNA, and from the ratios that come out of that analysis, we can again identify it as a kind of a natural source or possibly a human source, and that human source would likely be from failed septic or something like that, some type of illicit connection.
So Jamie, did you get a result from the genetic testing?
I haven't got the results back. So this is something that, again, I have to go beat on some graduate students to push those results out. That's one of the things we can do a lot at the university. When we pay for this, we get it quickly. When we rely on kind of the research, I have to follow up and have to get that back. So that's something on my list. But again, we're recommending just a continued investigation, and this would be the first part of it. And we never really trust one sample. Realistically, we'd like to do multiple samples, because especially with bacteria, gosh, it's really hard to put your finger on. Like after decades of research of fecal indicator bacteria, what we can say statistically is that bacteria increase in the warm months and decrease in the cold months. And I say that kind of jokingly because that's not very, that's not a very huge finding, right? But suffice it to say, bacteria is a very mind-boggling pursuit. So non-structural. So again, we recommend a range of non-structural controls, and it doesn't mean that you should be doing this. It means that, hey, here are some things to think about. And if one of these catches your fancy and you think that it could really fly, there are resources to fund these types of events. And we're really in the beginning of developing these types of programs. So fertilizer program, as Don mentioned, just instituting a ban on phosphorus fertilizers. That's been done in some areas, and it's something that we could consider and couple that with a education campaign. There's a high potential for load reduction just from those activities. Street sweeping, we try to estimate, sweeping streets around in the perimeter of the lake. We say within the 650-foot setback could increase street sweeping, especially during times of high deposition, like in the fall, in the spring, could potentially reduce phosphorus loads. And it's
yeah, Jamie, I don't mean to interrupt, and I'm not speaking for the highway department, but we do sweep in the spring around May. We don't use vacuum anymore. We just sweep it and pick it up.
Yep.
So we do sweep, and we do sweep most of the roads, I think, at least paved roads, and then pick it up and dispose of that mixture of sand, salt, and debris, whatever it is.
Yeah, so most sweeping programs are centered around the spring to remove the excess sand from de-icing, anti-icing operations. This would be kind of a more concentrated effort, more around the fall times during leaf deposition. Some of the research has shown that up to 80% of the phosphorus load actually occurs during the fall. And, so it's an area of rapid development right now. Sally and I are part of a expert panel process right now where we're considering how we actually model the load reduction. So we're saying, 1.13 pounds per year of phosphorus. That's according to the current way that we're tracking and accounting for this removal. A lot of the new research is showing that really targeted sweeping operations during the fall, as you get deposition of leaves, can help demobilize, like I said, up to 80% of the phosphorus. So it's a little experimental. And again, if it's something that you want to pursue, or you think that the DPW would be amenable to, because it's relatively easy and they may have the equipment, these numbers, could be increasing. Street sweeping intersects with leaf litter management. And again, when we're talking about sweeping or leaf litter management, we're really talking about targeted operations around the fall months. So more frequent sweeping and pickup during the fall months. It's been, the way we actually pick up leaves around these roads that are ringing, that ring the shoreline is changing. And we know it's likely a combination of activities. So again, high potential load reduction with minimal cost, as compared to some other strategies. Next slide. Shoreline buffer. So, the state has a Shoreline Protection Act that regulates certain activities within the shoreline. Some communities have enacted shoreline protection acts as well that, again, regulate activities within the shoreline. This could be an area of high potential load, assuming that, the population is amenable to like no-mow buffers or enhancing buffers on their properties. We all know people pay for access and want access to the lake. And we're not talking about getting rid of that, but we're talking about just changing the activities, especially within the shoreline, and reducing the amount of mowing and management or hardening of the areas in that zone. Catch basin cleaning, this is relatively low since the amount of catch basins in the area, are few, but certainly in those direct discharge areas, that's where you have infrastructure. So just cleaning them out regularly. And the goal is most of these catch basins have sumps. Many of them are 2 to 4 feet, depending on when they were installed. And the guidance is maintaining the sump levels to 50% or less full. And that's just vectoring. And even if these are state-owned roads, it's advocating to the DOT to, keep up with that maintenance as well. And then regulations. So updated stormwater regulations, updated shoreland regulations and what you can do in the shoreland, like hardening. Those are all things that can help manage load reductions and decrease load reductions over time. Next slide. And of course, we get to land conservation is always top priority. It's something that in this area has already been done pretty effectively. So, both of those large tributaries have lots of conserved land, and it's still a strategy, right? That's available. And then impervious cover disconnection, we rate it as very high. That there's just lots of opportunities to reduce the pavement and the impervious cover around these areas, whether it's through disconnection through structural BMPs, rain gardens, bioswales, or whether it's just removing pavement, the unnecessary pavement altogether. So that's something that could generally be done. We made some just simple assumptions of what could be done within this 425-foot shoreline area. And if we reduce 20% of the impervious area, it would have a huge potential load reduction. What that looks like on the ground and as an implementation effort, again, is something that is part of the next steps. And so what we're really looking for here is we're kind of throwing the range of options and hoping that something sticks and there's something that you can key in on as a next step to pursue. Next slide. And that's really where we get to Sally. So I've shown you a range of options, and now it's time to kind of hone in on what gets you really excited.
She's the money lady.
Right. How are we going to pay for this stuff? So, yeah, thank you, Jamie. I think as Don mentioned earlier, in order to prevent cyanobacteria blooms, we need to prevent roughly 66 pounds of phosphorus from reaching the lake. And then in theory, that will help. That will be sort of a way that we can prevent cyanobacteria blooms from happening. We can get that in-lake phosphorus concentration down so there's not enough, as much food in the lake to fuel the blooms. And then as Jamie presented, there are strategies that we can take on the landscape that can reduce the phosphorus load to the lake so that we can slowly make incremental progress toward attaining that load reduction goal of 66 pounds. So I'm just going to talk a little bit here about how we might pay for some of this work that Jamie presented. Some of the things that you'll see as I go through this are going to look very similar to what Jamie showed. And that is because in order to be eligible for implementation funding through DES, the activity that you seek to fund to reduce the phosphorus loading has to be presented as a recommendation in the plan. That's a requirement of our grants. So we'll talk a little bit about that, and then I'll show you actual implementation tables from the plan so that you can see what those look like, so that as you become more familiar with the plan, you can look in there and look at these tables and say, oh, you know, the rain garden at the picnic area, that seems like a project that we could tackle. You know, let's put a grant together to get funding for that activity and reduce some phosphorus loading to the lake. Kyle, yeah, could you advance it? Yeah, sorry, I was like clicking on the screen and then I remembered I don't have control. So the plan is done. It's in somewhat of a final draft form, and I believe, Kyle, correct me if I'm wrong, it's out for comment right now, and then we're going to tidy it up and sort of officially publish it. Is that correct?
Yeah, I believe, John, it's posted to the town's website. You're on mute, John.
Yeah, it is on the website. It's posted within the town hall. I have asked some of the Facebook colleagues to let people know it's there. So we'll just continue to push for reviews and questions. I think we did a reasonable job of publicizing that it would, you know, like today's meeting, and if you have comments, hopefully we'll get some more comments, hopefully.
Great. Yeah, so take a look at it, look through it, and, you know, let us know what you think about it. But it is, as I mentioned sort of earlier, you know, this is the start of being ready to implement some of these actions that are on the ground. Once you have a watershed management plan, an A through I style watershed management plan, as we sort of described early on, it does make you eligible for implementation funding from DES. So Kyle, go to the next slide. So how does that work? This is just an example here. Your plan is published, it's done. This is Nippo Lake's plan cover, looks very similar to yours. We have probably close to 75 completed A through I watershed-based plans in the state. And once the plan is done and it's published and ready to go, then you can apply to the New Hampshire Department of Environmental Services for implementation funding through our Watershed Assistance Grants Program. And what you see on the screen in front of you is an example of our pre-proposal form. We release them every year in June. They're due in September. And that's where you put together the projects that you and your local project partners want to do. It's a completely voluntary program. You are not required to do any of the stuff in your plan. However, if you don't do the stuff in your plan, then in theory, you're not going to get those load reductions you need to see improved water quality and to prevent cyanobacteria blooms. And then once you get the grant funding through us, then you're able to implement things on the ground. And that can be any of the structural projects that Jamie described. It can be non-structural work, and it can be septic system work, which I'll talk about in a little bit. The project picture on the bottom there is a project that Jamie and I worked on up on, I think that's in Wakefield, it's on Level Lake, because they have an A through I plan up there as well. So you're in good company once you have one of these. There's a lot of groups across the state. In fact, Dawn works with some groups that are working on implementing these A through I plans. And they're long-term relationships. Like once you get your plan done, you can come back to us year after year to get funding to implement the recommendations in your plan. So it's not a one and done kind of thing. It's not like, oh, we fund a rain garden, we're not going to fund it again. You can apply to us multiple times year after year until you reach your target or until your lake comes off the 303D list. Babusick Lake is a great example. They're down in southern New Hampshire. They did a plan 20 years ago, and they've been working sort of systematically over time to address phosphorus load reductions from their roads, from their private areas along the lakeshore, from septic systems, and through outreach. And they actually met their target phosphorus load reduction, and in-lake concentrations of phosphorus improved such that they were able to remove the lake from the impaired waters list, that's like the holy grail of watershed management. But that took a long time. You know, they had a really engaged local group, and they just kept coming back to us year after year to fund the recommendations in their plan. So that's what we would be talking about here, is that we would put together, you know, a local partnership. Perhaps Stratford Regional Planning Commission could be the applicant and could assist with applying for grants and potentially manage them if, you know, you feel like you need extra capacity to do grant management. Sometimes we have nonprofits that are all volunteer groups that'll take these grants on and manage them on their own, and that's a lot of work. But, you know, if there's a local partner like SRPC who's willing to help with the grant process, that can be helpful as well. Okay, Kyle, next slide. This is just a close-up of the pre-proposal. I think I covered this already. Annual grants, you can come back to us again and again. Your pre-proposal would go into a competition that's statewide, and if it's selected to go to the full proposal stage, that's when we would talk about further scoping your project so that we could get the funding to you. And that usually happens in the late fall. So like if you guys wanted to apply this year, what would happen is we would talk between now and when this, you know, pre-proposal is due, which is September. They come out in June, they're due in September, and we would put together a package of projects. It would go into the competition. If it's selected, then you would go on to develop a full proposal and a full project scope. And that happens in the late fall. And then we would go on to contract it. And then funding is usually available like a year later. So funding for this would be available in the spring of 2023 to do the project.
Yeah. Sound like a quick question.
Sure.
A lot of these projects require, or they appear to require, some kind of expertise in developing the project plan itself, correct? So to put these together, we would have to develop a plan either privately or with commercial help, you know, like let's talk about best management practice on roads or something, or whatever, rain gardens. Do we need professional landscapers to come in and propose this stuff? And I know that in my little project and in my house, I had a professional come up and draw plans. But that does cost resources. So go ahead.
Yeah, I know what you're saying. And so I don't mean to jump in, but
no, go ahead.
The way this works is you've been provided the technical expertise to get the grant. Now, I think the question fundamentally, so you don't need anything additional to get the grant. You have to identify one of these management activities that you want to address.
Oh, okay.
And what's in this report is sufficient to apply for a range of those solutions, because what we've done is we've outlined the management activity, we've outlined the potential load reduction, we've even, for the most part, outlined the cost. And so you shouldn't need additional technical expertise to get the funding. However, the funding may include, you know, expertise around constructing a rain garden, right? And so that would be included in the grant funding, and you would likely compete that technical expertise as part of the conditions of the grant.
Yeah, that's pretty assuring. Yeah, that's helpful, at least.
Yeah, Jamie's right. We have enough information, and Kyle, you can go to the next slide here. We kind of have enough information based on the work that you know, Jamie and Renee have done to be able to do, put a proposal forward. If further design is needed, or if permitting is needed, or if construction services are needed, that is something that we can pay for through the implementation grant. But I think Jamie's correct. We have enough information right now. We know enough about these projects to be able to put into a suggestion into a pre-proposal. So, and I think this is a great segue because right now you'll see the table from the plan that says structural. This is essentially the table that Jamie showed, but this is actually from the plan. So if we were thinking of doing construction activities, you know, we could look through here, we could pick some projects from this table to put forward for implementation funding. At the bottom of this slide, you'll see an example. That's a project that was done up on Province Lake. That project showed up in a watershed management plan as stabilized road shoulders with swales, and then it was constructed. Jamie assisted with that. They did some design work on it, and then the town helped with construction. The grant paid for some design work and it paid for materials, and then matching funds were provided by the town through construction services. So that's just kind of an example of how this would work. You know, the Province Lake folks, they looked at their structural list that's much like this one, and they said, we want to work on Bonnyman Road. We want to do this project. Put that project into a pre-proposal and then receive funding to build it. And that's what you see there in the photo. Next slide. So soak up the rain, Kyle mentioned that earlier, and I just wanted to revisit it again, is that we can fund fixes on residential properties. You know, one of the ways we know that phosphorus gets to the lake is through erosion. So if we can reduce erosion from residential properties, we can, in theory, reduce phosphorus loading to the lake. Again, those reductions are kind of small, but they do add up over time. And we are certainly willing, as Kyle mentioned earlier, to come back to Sunrise Lake and to do more soak up the rain and residential work. So I just wanted to throw that out there, that those projects are fundable, if you will, and we can provide technical assistance to get things in the ground. We can also come back out and do more surveys. So you know, it may make sense to think about, you know, erosion from residential areas and ways to prevent that. A lot of these fixes are super simple. You can see some photos down below from some other lakes. In the middle are sort of what we call erosion control steps or infiltration steps. And basically what happened there is a pathway to the lake that was eroding and transporting sediment to the lake was stabilized through these very simple infiltration steps that stabilize the slope and allow the water to infiltrate into the ground versus just eroding away into the ground. Also next to that, you'll see folks putting in what's called a rubber razor. It's a water diversion device that was installed on a driveway near Nipple Lake. And again, what was happening there is that water was running down this driveway and causing erosion and transporting sediment and phosphorus to the lake. So this very simple diversion device was installed to direct the water into the forest versus down the driveway and into the lake. So those are just kind of examples of some of the things that we can fund through these grants. Next slide. So Jamie mentioned non-structural practices to reduce phosphorus loading to the pond. We can also fund some of those things as well. We could fund, you know, help to develop a leaf litter management program, or we could fund, we've funded catch basin cleaning. Although you don't have a lot of catch basins in your watershed, it is something we have funded. We could maybe fund street sweeping. So say like, I don't know if Middleton owns a street sweeper. If you don't, grant funds could be used to pay to have it come back in the fall or something like that. And I think we might have done that in one watershed. So the non-structural practices are also eligible for implementation funds. And we could certainly sit and talk about what that might look like, you know, a fertilizer reduction campaign or something like that. That is something that we could fund, you know, the development of the program, staff time for someone, say like maybe from Kyle's shop to implement it. But those are non-structural practices are eligible. And so this is, when you look in the plan, this is the non-structural table. This is what it looks like. And that's where you might find some additional projects. Because as Dawn mentioned, you know, the phosphorus reductions are going to have to come from all buckets to get to that 66. And you're not going to get there with just structural, non-structural and alone. You're going to have to work on a broad front. Okay, next slide. living shorelines. This is we dug a little deeper into Renee and Jamie's recommendations for non-structural approaches to do buffer restoration, and kind of looked at some projects that have been done on other lakes, and put recommendations in there for using natural approaches to stabilize shorelines. And typically, you know, on your lake, this would primarily be on private property, but if you do have areas where folks are interested in doing this kind of work, implementation grants can be used to sort of design and implement natural approaches for stabilizing shorelines. And you can get some pretty decent load reductions for that work. On the bottom, you'll see a picture of some plants near a guardrail. That is work that was done up on Province Lake to reduce the effects of sheet flow erosion from Route 153 going across the beach there at the southern end of Province. And that is a project that we funded. Youth Conservation Corps kids actually did that installation, and it was pretty effective at preventing erosion. It needs some maintenance. All of these things that you build or plant do need maintenance because its efficacy is kind of reduced over time, you know, as foot traffic and whatnot. But the YCC kind of goes out there and tends those plants every year and looks at them and makes sure everything's going okay for them. Okay, next slide. Septic systems. Okay, so this is always, I don't know if anyone ever saw Linda Shire and I do the elephant in the outhouse presentation about watershed plan implementation, but septic systems are always really, really challenging to do implementation work to address phosphorus loading from septic systems. Because they're expensive, they're privately owned, it's just a challenge. However, we have had success in some watersheds working with lake associations and others to do septic system prioritization work. So basically, you kind of look around your lake, you dig a little deeper into your septic survey information, and you look to find septic systems that are older, closer to the lake, and maybe, you know, haven't been upgraded in a while. We can fund, our grant funds can fund cost share replacements for those septic systems, as long as we do a little additional prioritization work and can show that the septic system is older, is close to the lake, and is potentially deficient in some way. We can provide grant funding to cost share replacement of that system. This is always a little controversial, but it does work, and you do get load reductions from doing that, and it does check the box of working on that bucket. So in the Acton sort of Wakefield, Salmon Falls, Headwaters Lakes region, we have replaced, I think, close to 10 septic systems now through cost sharing on Level Lake, Great East Lake, and I think one on Horn Pond. Additionally, we've cost shared replacement of up to 8 septic systems on Province Lake, and that has gotten us about 10 to 12 pounds of phosphorus reduced to Province Lake. Again, it's a process, but we do have kind of a template for that process, thanks to the work that was done up in the Acton Wakefield region. We also, Lake Waukesha has also done similar work to do some cost share replacement for septic systems. So it is something that we can fund. Again, you know, it's challenging, it's controversial. Generally, watershed groups that I work with, they'll do some of the easier, funner stuff first. Like they'll do outreach and they'll do BMPs and rain gardens, and then work on septic systems once they've kind of got their feet underneath them and they're ready to tackle something more challenging. We can also cost share replacement of community septic systems. I have not had success with any of my groups in getting one of these things in the ground. But basically that concept is that you would take a bunch of older systems and you would hook them up to one community septic system. Instead of having all these individual septic systems, you know, you manage it kind of in one location. And that in theory can help reduce the phosphorus loading, because you're putting everybody's stuff into one place where it's easier to manage and keep an eye on. Babusick Lake, they did do a community septic system there on that lake, and they hooked up, I think it was 23 cottages to a community septic system. But you know, it's a voluntary thing, and there has to be the interest, and there has to be the capacity to want to do that kind of thing. but there is funding available to do that sort of work if folks are interested. Again, this is all voluntary stuff, but it is something that's available. You could also explore doing septic system regulations. We had some success down in Rye, establishing a health regulation that requires pump outs of septic systems within a certain distance of a creek. And the pump out is required like every 3 years or something like that. But again, that's something that has to be of interest to your community. And, you know, you have to see if that's something that will fly. It doesn't work for everyone. But septic systems they do contribute phosphorus, and they do, you can get phosphorus load reductions by doing some septic system improvement work. Next slide. So we included some recommendations in the plan to address waterfowl. I think we had heard concerns that in areas there's waterfowl that congregate in sort of, it's more of like a locally specific kind of situation where they congregate. So we included some recommendations for waterfowl management, if that's of interest to residents on the lake. Through our implementation grants, we have funded waterfowl control projects. So we wanted to make sure, again, that it's a recommendation that shows up in the plan. You may decide that's something you don't want to do right now, but in order for us to consider it for funding, it's got to be contained in the plan. So we put it in there, and there it is. So if that's something folks are interested in, you know, it's something that you could consider working on. Next slide. And then regulatory mechanisms. So Kyle came up with a lot of really good sort of lake specific regulatory approaches and solutions for potentially reducing phosphorus loading. And again, you know, this is just a screenshot from the plan. So when you look in the plan, you can see what he's proposed. And we could fund work to develop these regulatory mechanisms as well if there was local interest in developing and implementing any of those mechanisms. Next slide. Outreach. Again, we included outreach recommendations in the plan, and we can provide funding for outreach. We've funded fertilizer campaigns, pet waste campaigns, general sort of lake-friendly living campaigns. We've funded numerous outreach initiatives through the years on these projects, and they can be really effective. They may not, you know, get you a big phosphorus load reduction, but it certainly helps raise awareness of what's happening in your watershed in ways that folks can sort of live more lake friendly so that they can reduce phosphorus loading and have a smaller phosphorus footprint. And next slide. Water quality monitoring. So Don talked a little bit about some of the water quality monitoring stuff that could be done to kind of improve your current program. We can also fund those activities as well. So that water quality monitoring could be a component of a pre-proposal. Next slide. We also included kind of toward the end of the plan, a list of other funding sources that are out there. And I just put an abbreviated list here because we're not the only game in town. There are other grant sources available to help with implementation activities. And it's sort of my job to help you not only put together a pre-proposal for implementation funding and a full proposal, and to help you through this process of transitioning from planning to implementation. That's what I do. But I can also assist you with these other sources as well. So like I said, we're not the only game in town, and you may find that you want to apply to some of these other grants opportunities or funding opportunities along the way. So we did include a section at the end of the plan that describes each one of those in a little bit more detail than what you see here. Some of them are state grants, some of them are foundation grants. You know, they're typically annual grant programs. So there are other funding sources out there. We just want to make sure that you guys are aware of that. Next slide. All right, so I'm going to kind of close it out here with just some examples, an example from Province Lake. So Province Lake, your neighbor to the north, I think you guys have probably heard me talk about them before, but I think I talked about them earlier today, but they've been at this a long time now, and they've had 3 implementation grants from us. They started out on the same path as you guys did. They did a watershed-based plan. They really didn't want to do a watershed-based plan. They thought it was going to be painful and, just take forever, but eventually they did it, and it was published in 2014. And since then, they've had 3 implementation grants, and they've built probably over 15 different projects. That's structural projects. They've also done a ton of outreach, and they've done some non-structural stuff like fertilizer campaigns, and they've done some land conservation workshops. And so they've done like a whole range of different things. They've done the septic system cost share replacement program that I mentioned earlier. And so to date, they have reduced the phosphorus load to their lake by about 100 pounds. Now your load reduction is 66. So they've gotten about 100 pounds of phosphorus reduced. And that's about 40% of the way toward achieving their water quality goal. So they're still at it. But I think this just illustrates that, this work can be done. It takes a long time, and it takes a lot of persistence and sense of humor, and some patience. But you can do it. And I think that, they're a great success story to me, because they keep trying, and they have achieved, some pretty good, decent load reductions through their efforts. And they've had, like I said, they've had numerous grants from us, plus they've had grants from some of those other sources I showed. So you're not alone in this work. There's a lot of folks around you who are doing it. And, I'm just looking forward to continuing this work together. And as I said, I can help with developing your projects for a pre-proposal. I can help pull the pre-proposal together and just kind of help you along this next step of the way as we move toward implementation. And with that, I think that's it. Right, Kyle? Yep. So congratulations on the completion of your watershed plan. It's a big accomplishment.
Yeah, I think with that, I'll just offer it up to, if folks have any other questions, Eric or John or Dean or Carol, if you guys have any questions for us, or I'll just sort of open up the floor to anybody.
I have a question for the Sunrise Lake Association beach, where you saw that drain pipe. How much would that cost to fix, or how can we fix that? I'm having a hard time visualizing exactly where it is. Will we need to go into the road to fix that?
No, it's not under the road. So on the other side of the road, there, it looks like it was recently replaced, because it's not corrugated metal. So it's HDPE pipe.
Mhm.
And so somewhere in the road or just after the road, there is some blind turn. And I say blind, meaning that there's a turn in the pipe without a structure above it or a manhole access. And generally we don't do that anymore, but my guess is you just track it back to wherever that union is. That would be the best approach. And then possibly drop a structure and a pipe. That would be a comprehensive approach. And I would say, yeah, that's in the $10,000 range. Again, depending on how much DPW equipment can be used. If you can use DPW backhoe and digging equipment, that will reduce the cost significantly, because the pipe and the structure are probably about $1,000 in material. And then add to that another $1,000 in select aggregate to bed the pipe in. And you get maybe $2,000 worth of material in there. The rest is going to be equipment, heavy equipment. Cheap, there's lots of ways to do this. So that would be the recommendation. You could even find a smaller diameter pipe and push it down beyond the breach, right? That would be a very cheap temporary solution. That would be $100 to $200. And then slip line, I don't know what slip lining cost. I did meet someone who is in the neighborhood that was walking while we were scoping, and he was like, oh, this looks familiar. He used to work for Mass DOT, and he'd slip line all kinds. He was telling me that, you know, that's what his job was, slip lining pipe. And so, you know, if that was what slip lining is it's like a polymer, and you push it in, and then it hardens within the pipe. So it actually forms a new, it's sort of like the Mickey Mouse approach would be to jam a smaller diameter pipe inside there up to the breach. This would be a better solution to that, right? A more permanent solution. Slip lining forms a epoxy line that matches the dimension of the existing pipe and then just lines it. So there's 3 alternatives there, from $200 to $10,000.
How long would I want to do it the right way and the longer lasting way, because it just makes sense. I don't want to, you know, patch something and then 2 years later have to go back to the association and say, oh, you know, the job needs to be redone. How long would it last if we did it the correct way or the ideal way?
The ideal way, typically we give infrastructure a 20-year life cycle.
Okay.
So, you know, that's our typical estimate. We have pipe that is hundreds of years old. In Portsmouth, they're digging up a wooden pipe, you know, like that was done 300 years ago. But my recommendation would be get a smaller diameter size of, they call it SDR. It's kind of like a PVC. It's like a green pipe. Push that up for now so that you'll solve the immediate problem of the erosion control, and then add in a grant potentially, the better fix, right? Because it could take, if you want to get it funded, it could take more over a year.
Okay.
Sally, one of the things we didn't do that I realized is it was hard to estimate the load reduction, but we could do like a Region 5 model estimate, right? For
the beach. Yeah, totally. Yep. We could come up with a load reduction estimate for that.
Yeah, and Sally's a really great resource. Again, to she really helps you formulate the plan and how to do it. And she has great connections with people all through the industry. So if you need an estimate, either she does it or she'll ask someone to do it. And most of us are very generous with our time to help Sally.
Great.
Yeah, we just need to know enough to get it into the pre-proposal and then have a ballpark figure. A lot of the budgeting that we do for this is pretty ballparky. And then once we get closer to the full proposal stage where the budget really needs to tighten down, that's when we start to kind of put the numbers together a little bit more. But even then, the full proposals are just budget estimates. So we do our best to make sure that we're going to cover the funding and the match, because local match are required. A match is required with our grants, and that can either be cash, or it can be volunteer time, or it can be materials, or it can be labor and equipment. It sounds scary, I think, to a lot of groups when they realize they have to come up with a match, but the reality is that I've never really encountered too much difficulty coming up with that match, because often, you guys are all volunteers. Your time counts as match, and people put in a lot of time on these things. And if we have DPW helping, that counts as match. And there's a lot of creative ways to fulfill that requirement. So we just, it's a process. And as Jamie said, I can help. So.
Great.
Sally, I just wanted to just kind of build off of what you're saying with the match. And so for this particular project, we had $5,000 worth of match that was required in putting together this plan, which was all in kind. And so, that was folks' participation in the kickoff meetings, the back and forth with questions, folks that participated in the soak tours, John's participation, we were able to use his boat as equipment. There's a number that we could actually associate with a boat his size, and those numbers. So that all adds up. And so, you know, this plan, while there was a $5,000 match requirement, there was no cash that was involved with the town. It was all made up from in-kind contributions over the course of the year. So to sort of reiterate Sally's point, you know, 5,000, you know, or whatever it may, you know, sound like a lot, but once you get a couple of groups together, the volunteer rate is almost like $30 an hour. It's, you know, so your time participating, essentially they view that as, you know, almost a $30 an hour value. So it does add up. Any other questions, or John?
No. Question. So what's next?
No, what's next is that, you know, we will post this, you know, once the video is uploaded to YouTube, we will share that. John, if you wouldn't mind sending me your comments to your highlighted comments for the plan. I think I know that we were going to take one last look through it. I don't know, Sally, if we want, like, how long. Technically, our grant ended December 31st, so we can't really, you know, we can't code any more time to it. But I'm happy if, you know, within the next week or two, if there are folks that have comments on the plan, I'm happy to make those changes, because I don't think that they're going to be these ginormous like changes where we're messing, you know, we're kind of messing with the formatting. But if there are tweaks that need to be made here and there over the course of the next 2 weeks, I'm happy to do that. At some point, we need to kind of make a cutoff so I can submit that, you know, close out the grant, and then have it be sort of reviewed at the state level. But over the, like, you know, Sally, if it's okay with you, I'm happy to wait another week or so, you know, the end of next week, to get any comments back. And then what we'll do is we'll finalize the plan. I'll submit that to DES. And then I think, this is just my thought, is, you know, if there are discussions about if the town or one of the, you know, the watershed associations, either one or all three of them together, you know, want to do something, then I think we should start talking like relatively soon to be ready for the summer for that pre-proposal. And again, the Planning Commission is happy to help and act as the fiscal agent and be your grant administrator and help write a proposal. We're happy to do that. You know, I would just want to make sure that there's enough buy-in at the local levels, so it doesn't seem as though we're pushing this on the town. I want to make sure that it's a local sort of grassroots effort, that the support is there. We're just helping, kind of facilitating and offering the technical assistance. So I'm happy to keep the conversation going. And, you know, whatever you guys decide to do, you know, I would just strongly encourage you to do, I mean, now that you have this plan, I would certainly encourage you to apply for something. It can't hurt to do something, or be ready to apply in the summer.
I when you put this recording out, enable it to put on the website, I would encourage in that note, or we can, if you have comments, residents, make them by January 15th. And as far as the buy-in by town officials, my feeling about the board and the other boards and commissions are backing the lake for the most part, and the board is always looking, this is just my opinion, always looking at the financial commitment, always. So, but that being said, I was encouraged by the grants, the availability of the grants. I wasn't aware that the plan gives us sufficient information to go ahead. Also keep in mind that the Board of Selectmen in its current form is not going to be around for another 10 weeks. After 10 weeks, it could be a new board because we have 2 open slots, right, Christine? I think.
Yeah.
2 open slots. Now, that's not saying that the new board would change their attitude, because I think the town as a whole supports the lake and what it does for the town, what it does for each resident on the lake and the residents of the town. So, the current board is very busy with planning for town meeting and budgets and everything else. I am certainly going to, and if Christine wants to join me, or Carol or anybody else, go before the board and present the plan and say, these are some of the things that we've thought about, and see where they might commit or not commit, at least right away. And I agree with you in terms of getting some of these going. Some of these, at least like Sally said, outreach would be a first good start, but there's some easy ones that we could do that don't cost a lot of resources or thinking about right away. Like the beach thing. I think there's some things that can be done with that before the summer starts, so your beach doesn't wash away, just like Jamie said, as a stopgap, because that's a pretty big concern of the residents down at the Lakelands Association down there, and their beach. Their beach is their joy. So we want to, at least I would want to push that first. But there's some things I think the town will buy into a lot of the things. The septic thing is going to be another, like Sally said, is always a challenge. There's going to be some people that more than willing to do certain things. Some people are going to be unwilling to do certain things. So that's just a matter of education and time. I think this is a great start personally, and I've been a pleasure to be involved with this thing. And because my life revolves around the lake, it has since 2002. So this is a great plan to start with. And you're right, Sally, this isn't going to be done in 1 or 2 years. It's going to take us some time, but I think we can be successful. So thank you very much to all of you who did this up. Jamie and Don, Sally, Jamie, or Kyle, you've been a big help. Christine, you've been instrumental since the beginning. Carol, you've made some input, appreciate it. So thank you very much.
Yeah, and John, I think that's a really good way to kind of close this out is, this was, and I've said this to the project team before, this was my first watershed plan, and it was a pleasure to work with this team and with, folks at the local level. As Sally said, the work will continue. And so let's just keep in touch. I will, once this is uploaded to our YouTube, I'll share it. I'll put a note that, we're looking for comments by the 14th, which would be next Friday. And then, as you have conversations with with your associations and with the Board of Selectmen, if, whenever you want to circle back with me on, talking more about what you'd like to do, you know how to reach me, and so we can go from there. But again, it's been a pleasure. This was a great project to work with, and I'm excited about starting to implement some of the actions.
Thank you.
Yeah, likewise. So let's maybe let a little time pass with the watershed plan getting finalized and out there, and then let's plan to check in, I don't know, later this winter to see where everyone's at. Would it be helpful if I shared? So Jamie and Dawn and Renee also worked with me on a watershed plan down on Country Pond, and that group just completed their plan and submitted a pre-proposal. And if you'd like, I could share that pre-proposal so you can see kind of what that looks like. I sometimes feel like, for me, I always like to look at what other folks have done, and find that helpful. I mean, they actually bit off a lot. They submitted a pre-proposal to fix a boat launch ramp and some roads. So it's going to look big when you look at it. But it is an example of a group that recently had their plan completed with science done by Dawn and recommendations done by Jamie and Renee. And then they turned that into a pre-proposal, submitted it to us. It was selected to move forward for funding. And that's kind of what we're in the process of doing now, is negotiating the fundable budget. But if it would help, I can share that around. I'm sure they don't mind. So
I think that would, personally, I think it would. I think that would give us just some additional information to present to the parties within the town, not only residents, but the boards and commissions and so forth. So that would be helpful.
Great. Well, if there aren't any other questions, thanks again to everybody. And we